Going to go over the last section, 7E, counting and probability. So let's take a look at the counting principle, which is what we will use today. And that is, if the first experiment can be performed m distinct ways, and the second experiment can be performed in n distinct ways, then the two experiments in that order can be performed m times n distinct ways. What this means is when it says first experiment, let's not focus on the word experiment too much. We're looking at how many ways can something be arranged. And if the first, they call it experiment, but if the first thing you're doing has m ways of being done, we're just giving it a letter m, and the second thing you're interested in can be done in n ways, then to see how many arrangements there are, you multiply those two together, m times n. So you'll see in this section, all of this section is about in how many ways can something be arranged. So let's look at the first example. Again, this is called the counting principle. We are going to use that below. License plates. So they are 3 letters and 3 digits in that order. And so the question is, how many ways can this be done if repetition is allowed? So we have a license plate. So I would write this. I have 3 letters. So I'm going to write letter 1, letter 2, letter 3, and 3 digits. So digit 1, digit 2, digit 3. So let's call this my first experiment. There's like 6 experiments here. And so how many ways are there to put a letter? Or how many types, or what is the number of letters? So in that case, there are 26 letters to choose from for my first letter, because there are 26 letters in the alphabet. And then when I go to select my second letter, because repetition is allowed, there are also 26 letters to choose from. And when I go to select my third letter, again, there are 26 letters to choose from. Next, I'm looking at the digits. And when we say digits, we're talking about single digits. So from 0 to 9. From 0 to 9, there are 10 values there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you count that, that's 10 options, 10 ways. And again, because repetition is allowed, when you go to select your second digit, you also have 10 numbers to choose from. And your third digit, 10 numbers to choose from. And so what the counting principle says is multiply the ways that each of these can be done. And so if you multiply this on the calculator, 26 times 26 times 26 times 10 times 10 times 10, you'll get 17,576,000. That is the number of ways that the license plate can be arranged when repetition is allowed. Let's look at this next example. So we still have this license plate that is 3 letters followed by 3 digits. So again, just to be organized, I'm writing letter 1, letter 2, letter 3, digit 1, digit 2, and digit 3. And now we are saying no repetition is allowed. So when I go to select a letter, we have 26 letters in the alphabet. So I have 26 letters to choose from. When I go to select my second letter, because I cannot repeat and the first letter is chosen, I only have 25 letters to choose from now. And the third letter, now the first two letters are chosen. Remember, there's 26 letters in the alphabet, but the first two, letter 1 and letter 2, are taken. So that leaves me with only 24 letters to choose from. And now we're on to the digits. From 0 to 9, we noted there are 10 digits to choose from. When you go to put your second digit for your license plate, remember one digit is already taken. So now there's only 9 to choose from, and then next 8. And the counting principle says multiply these together. And if we do that, you should get 11,232,000. So license plates, you have 3 letters followed by 3 digits. And now it's saying the first letter has to be a vowel. Well, the vowels are A, E, I, O, U. So there are 5 options there. The second letter is a consonant. A consonant are all the other letters that are not vowels. There are 21 consonants. Now, when it comes to the third letter, we know there are 26 letters in the alphabet. You see L1 and L2, that means 2 letters were taken. So there's only 24 options left. And now for our digits, it says no digit can be 0 and there's no repetition. So if no digit can be 0, then I'm limited to 1 through 9. And 1 through 9 means there are 9 options to choose from. And now when I go to select my second digit, because the first digit is already gone, I should have 1 less and 1 less because of no repetition here. And again, the counting principle says multiply the ways that this can be done. And if you do that, you should get 1,270,080. Okay, let's look at the next one. So it says you have 6 pictures of different people to hang on a wall in a row. How many ways can you arrange this? So let's put 6 spaces here. I have 6 pictures. When I go to select my first picture, or hang my first picture, I should say, there are 6 pictures to choose from. Now I've hung the first picture. So when I go back to look at how many pictures I have left, there's only 5 to choose from. So now I've hung 2. And when I go to select another picture, there's only 4 to choose from. And hopefully you're seeing a pattern. It's going to continue to go down to 1. And so again, counting principle says multiply these and you will get 720 ways that you can hang these frames. Let's look at part B. You still have 6 frames. So I'm putting 6 spaces there. And it says, suppose the third and the fourth position decided to be 2 specific people in any order. How many ways can this be done? So there's some specifications for the third and the fourth position. So I'm just noting that there. So for the third and fourth position, it has to be between 2 specific people. So for the third position, I have 2 options to choose from because it can only be among 2 specific people. So now I put the third option there. I select one of those two, which means there's only one left for the fourth position. Now we can go back to the first frame. Remember, we have 6 frames. 2 of them are gone now in the third and fourth position. So how many frames do I have to select from? 4. Followed by 3, then 2, then 1. Counting principle says we multiply this. And when we multiply this, we would get 48. There are 48 ways this can be done. So we're going to talk today about 2 different types of scenarios when we're talking about counting or arranging things. And one of them is permutation, and the other we'll talk about in a little bit is combination. And so we would use permutation when you have no repetition and order matters. That's the most important things to remember here. Permutation is used in a scenario where there is no repeating, there should be no repetition, and the order matters. And what I mean by order matters is, let's take a look at this example here. A, B, C, D is distinguished or different from D, C, B, A. Notice the same letters are present, but they count as 2 different things because the order matters. And so we can calculate the permutation. And so this is the formula for permutation right here. And I want to go over what this means. This P, capital P, stands for permutation. N, I wrote underneath here, represents the total number of objects. And R represents the number of objects that we would select. So the way this is read is the number of permutations of N items taken R at a time. Again, you use a permutation when order matters. There's a total of N objects, and we are taking R at a time. R is the number of items we are selecting. Now notice here in the example, in the formula, we have a exclamation point. This exclamation point is called factorial. It's called a factorial. And I wrote algebraically what that means here, but I'll explain it through an example. Let's say I gave you 3 factorial. How we calculate that is 3 times 2 times 1, which is 6. So in essence, what we're doing is we're taking the value 3 and we're multiplying it all the way down to 1. 5 factorial would be 5 times 4 times 3 times 2 times 1. 0 factorial, this is one that you have to know. If you ever see 0 factorial, it is a rule that 0 factorial is 1. So, with the knowledge of how we can work a factorial, we will use that to find our permutation. It is n factorial over n minus r, that's in parentheses, so I have to do that subtraction first with the factorial. So let's look at this example here, example 3. It says only part of the items to be arranged. The vowels are A, E, I, O, U, and it says, how many ways can you arrange 3 vowels with no repetition? So let's try to do this with a permutation. So with the permutation, we know it's a permutation problem because the order matters. Now, I have to know what's my N and what's my R. Because there is a total of 5 vowels, my N is 5. My R represents the number that I'm selecting, the number of items, or in this case, the number of vowels I'm selecting. And so the question says, how many ways can you arrange 3 vowels? So my R is 3. And so look above at what's in green above here, NPR. So this would be the number of permutations of 5 items taken R at a time. NPR means 5P3. And the formula for that is N factorial, which for me would be 5 factorial over 5 minus 3 in parentheses with a factorial. And so how would I solve here or simplify here? Well, 5 factorial, let's leave that on top, over 5 minus 3 is 2 with the factorial. And we know 5 factorial is 5 times 4 times 3 times, I'm going to stop here at 2 factorial. 2 factorial means 2 times 1. But there's a reason why I'm stopping there, and it's because in the denominator, I also have 2 factorial. So my goal is to cancel those. And so what I have left is just 5 times 4 times 3, which is 60. And that is my answer. Let's look at the next one. There are 10 members on a basketball team. The coach is going to randomly select a captain, a first alternate captain, and a second alternate captain. How many choices does he have? So again here, we recognize that this is a permutation problem because the order matters. There are different roles. So who I select for each role makes a difference. So this is a permutation problem, and then I identify what's my N and what's my R. Well, my N is I have 10 members total, and we are selecting captain, first alternate captain, second alternate captain. So we are selecting 3 positions. So we are doing NPR, which for us is 10P3. And so the formula is 10 factorial over 10 minus 3 factorial. This is 10 factorial over 7 factorial. And so let's break down 10 factorial. That's 10 times 9 times 8 times, I'm stopping at 7 factorial because the denominator has a 7 factorial. I can cancel those. And so really, I just am doing 10 times 9 times 8, which is 720. For combinations, it's similar. We don't want any repetition here, but here the order does not matter. These are situations where the order doesn't make a difference. Order does not matter. This is when you would use a combination. So the notation for a combination is NCR, where N still represents the total amount of items. R represents the number of items you're selecting. And the formula, I think this is the easier formula. I have one where it's NPR over R factorial, but I believe this is easier to look at. It's very similar to permutation, N factorial over N minus R factorial. The only additional piece is this, you're multiplying the denominator by an R factorial. That's what makes it different from the permutation formula. So once again, with combinations, order does not matter. So let's take a look at that. So let's look at this example here. It says, how many ways can you select two different vowels where order doesn't matter? This is reminding us that this is a combination now. Order doesn't matter. So I'm talking about vowels, A, E, I, O, U. There are 5 vowels, so N is 5. And my R is how many am I selecting? And it says, how many ways can you select 2 different vowels? But now the order doesn't matter. So the formula, let me write it here, is NCR, and that's n factorial over n minus r factorial times r factorial. So for us, that's 5C2, 5 factorial over 5 minus 2 factorial, 2 factorial. So this is 5 factorial over 5 minus 2 is 3 factorial, 2 factorial. Now you cannot multiply those factorials in the denominator and say that is 6 factorial. Algebraically, that is not correct. So when I break down 5 factorial, I'm going to go up to 3 factorial. And the reason why is because there's a 3 factorial in the denominator, and I want that to cancel. And so I'm going to go on the bottom here. 5 times 4 is what I have on the top. And then I have this 2 factorial in the denominator, which is just 2 times 1. And so what do I have on the top? 20 divided by, in the denominator, 2. And so 20 divided by 2 is 10. Let's look at the next example. We want to determine if this is a permutation or a combination. So it says 5 starters on a basketball team. How many ways can you choose a captain and an alternate captain? So remember, with permutation, the order matters. With combination, the order doesn't matter. So the way I can determine whether this is a scenario where order matters or not is think about 2 people. Let's call one person A and one person B. If I give person A the captain role and person B the alternate captain role, that's one option. Let's say I switch the order. Would me switching the order count as a second option? And in this case, yes. If I give person B the captain role now and person A the alternate captain role, that is a second option or a second way I can choose captain and alternate captain. It counts as another choice. So this is an instance where this is a permutation problem. Order matters. And so with that, we can determine what's our N and what's our R. And I usually just like to write that on the side. My N is the total. I have 5 starters. My R is the items I'm selecting. In this case, it's captain and alternate. So that's 2. And so what we're doing is, and I'll write the formula here, NPR. It is n factorial over n minus r factorial. So this is 5p2, 5 factorial over 5 minus 2 factorial. So this is 5 factorial over 3 factorial. And let's rewrite 5 factorial as 5 times 4 times 3 factorial over 3 factorial. And the reason why I stopped at 3 factorial on the numerator is so that those can cancel. And so I'm left with 5 times 4, which is 20. For part B, it says, how many ways can you choose 2 starters to discuss topics with the coach? Now, in this instance, remember you have 5 starters, right? And you just want to select 2 of them. I have to determine first, is this a permutation or a combination problem? And in this instance, think about it. If I select person A and person B to be the people to go to the coach, the 2 starters, that's one option, right? If I select person B, then person A, it's still the same 2 people. It doesn't count as any different, right? It's still the same group going. So in this instance, this is a combination. Here, order does not matter. B and A and B, they still count as the same 2 groups of people. So this is a combination problem. So my N is 5, my R is I'm selecting 2. So I'm doing 5C2. And let me write the combination formula on the side here. N factorial over N minus R factorial, R factorial. So this is 5 factorial over 5 minus 2 factorial, 2 factorial. And so we have 5 factorial over 3 factorial, 2 factorial. And once again, you cannot multiply those denominators and say that 6 factorial, that is incorrect. Multiply 5 times 4 times 3 factorial. And in the denominator, you have 3 factorial, 2 factorial. Those 3 factorials will cancel out, which leaves me with 5 times 4 on top over 2 times 1 in the denominator. And so this is 20 over 2, which is 10. Okay, you have a test in which there are 6 questions. You are required to select any 4 questions which are worth the same number of points. How many different tests are available to you? So again, I have to determine, is this a permutation or a combination? And so I have to then question, does the order matter here? If I pick the first, let's say 4 questions, you can select 4 questions, right? So let's say I pick the first 4. That's one option. And then let's say I select the same 4, but just in a different order. I say 2, 1, 4, 3. It's still the same 4 questions I'm selecting. So if you change the order and the order doesn't count as a different option, then the order does not matter. So in this case, this would be a combination problem. So I need to identify what's my N and what's my R. My N is there are 6 questions, right? Total. You have a test and there are 6 questions. You are required to select any 4. So my R, the amount I'm selecting, is 4. And so I'm doing N, C, R, 6C4. And the formula, you can refer to what I've boxed in above right there. This is 6 factorial over 6 minus 4 factorial, 4 factorial. This is 6 factorial over 2 factorial, 4 factorial. 6 minus 4 is 2 factorial. So now, rewrite 6 factorial as 6 times 5 times 4 factorial over 2 factorial, 4 factorial. And again, I planned this so that I can cancel those 4 factorials. And so what I have is on the top, 6 times 5, and in the denominator, 2 times 1. This is 30 divided by 2, which is 15. There are 15 ways that I can select 4 questions. And let's look at the last example. Priceless Pizza is offering a special on a 3-topping pizza. They have 8 different toppings available. How many different ways can you order a pizza with different toppings? So I have to consider, is this a permutation or a combination? So select 3 different toppings. Let's say you have sausage, mushroom, and pepperoni. I'm just going to abbreviate that. That's one pizza with 3 different toppings. If I change the order of these, meaning if I put pepperoni first on the pizza and then sausage, followed by mushroom, that's still the same pizza. Even though I put the toppings on the pizza in a different order, it's still counted as the same pizza. So because of that, the order doesn't matter. This is a combination once again. So let's determine our N. Our N would be the total amount of toppings. There are 8 different toppings available. We are only selecting 3, which would make 3 our R. So 8C3. And this is 8 factorial over 8 minus 3 factorial times 3 factorial. So I have 8 factorial over 8 minus 3 is 5 factorial, 3 factorial. And so let's rewrite 8 factorial as 8 times 7 times 6 times, I'm going to stop at 5 factorial there because I see a 5 factorial in the denominator. I want to cancel those two. And so I'm left with 8 times 7 times 6 over 3 times 2 times 1. That's what 3 factorial is. So if you multiply 8 times 7 times 6, that's 336. 3 times 2 times 1, that's 6. And when you divide that, you should get 56 as your total.